Hey everyone, welcome back. Today we're going deep on large language models in medicine.
Really exciting stuff.
It is, and to help us unpack it all, we've got this research paper. It's called Demystifying Large Language Models for Medicine. A primer.
A primer, yeah, that's a good way to put it.
Right. It's a complex topic, but this paper does a great job of breaking it down. And one of the things that really jumped out at me was just how much potential these LLMs have to completely revolutionize how we approach healthcare.
Yeah, no, it's not just hype anymore. This paper really lays out a practical roadmap, which is what we need right now.
For sure. So let's jump right in. The paper starts by outlining 5 core capabilities of LLMs in healthcare. The first one they talk about is knowledge and reasoning. So what does that actually look like in practice?
Well, imagine a doctor right in the middle of an appointment. They can get an answer to any medical question instantly. They've got access to this huge medical database, and the LLM can synthesize all that information and provide evidence-based support for their decisions. Potentially, that could really improve patient care.
Yeah, it's almost like having a super intelligent consultant on call 24/7.
Exactly. And it goes beyond just answering questions, right? Think about summarizing those super long patient records or those dense medical journal articles. LLMs can do that too. Saves clinicians so much time and, could even reduce errors.
So we're talking efficiency and accuracy, which are both essential in healthcare.
Absolutely. Then there's translation, and I don't just mean between languages. LLMs can also translate medical jargon into something that patients can actually understand.
Right, like bridging that communication gap between doctors and patients.
Exactly. And it can empower patients, help them understand their own health and participate in decisions.
Yeah, that's a huge win for patient engagement. What's next on the list?
Structurization. This is where LLMs can take all that unstructured data we have in healthcare, doctor's notes, discharge summaries, and convert it into structured formats. Think diagnosis codes, medication lists, all that.
So it's like organizing all that messy data into something we can actually analyze.
Right, and once it's structured, you can do so much with it, identify patterns, maybe even discover things we wouldn't have seen otherwise.
Wow, it's like LLMs are helping us unlock the full potential of all this data we collect. Okay, so that's 4 capabilities. What's the 5th?
This one is maybe the most exciting.
Yeah.
Multimodal data analysis.
Multimodal. Okay, break that down for me.
It means LLMs can handle more than just text. We're talking images, genomics, even data from wearable sensors. All of that can be integrated to create this comprehensive view of a patient.
So it's not just about one data point, it's about seeing the whole picture.
Precisely. But of course, with all these amazing capabilities comes a big question. How do we choose the right LLM for the job?
And the paper does a great job of addressing that, right? They lay out this clear model selection process.
Yeah. They talk about 3 main factors to consider. First, you've got to think about the task and the data. What problem are you trying to solve, and what kind of data are you working with?
So it's not a one-size-fits-all situation. You need the right tool for the job.
Exactly. The second factor is performance requirements. How accurate does this LLM need to be for this specific application? And how fast do you need those results? Practical considerations like how much computational power you have.
It's all about finding that sweet spot between what you need the LLM to do and what resources you have available.
Right. And then the last factor is the model interface. How do you actually want to interact with this LLM? Do you need a web app, an API, or something hosted locally?
And that decision can really impact things like cost and security, right?
For sure. And the paper does a really good job of comparing the pricing models for different types of LLMs, like those big proprietary ones like GPT-4 versus open source options like Llama.
Okay, so let's say we've gone through all that and we've picked our LLM. Now, how do we actually get it to do what we want? This is where prompt engineering comes in, right?
Absolutely. Prompt engineering is all about crafting those instructions for the LLM. It's like learning how to speak the LLM language so it understands exactly what you're asking.
The paper uses a great analogy. It's like giving instructions to a really skilled assistant. You have to be specific, clear, and anticipate any potential misunderstandings.
Love that analogy. And they go into detail about some really cool techniques like few-shot learning, where you give the LLM a few examples to show it what you want.
It's like giving it a little bit of training data, right?
Exactly. Even just a few examples can make a big difference. They also talk about this thing called chain of thought prompting.
Chain of thought, what's that?
It's basically encouraging the LLM to think step by step, to break down the problem. That can make the reasoning process more transparent, which is super important in medicine.
Right, because you need to be able to understand why the LLM is giving you a certain answer. Can't just be a black box.
Exactly. And then there's retrieval augmented generation, or ARG.
ARGO. Okay, another acronym. What does that one stand for?
Well, it's all about giving the LLM access to external information, like a curated medical database. That way, you can be more confident that its answers are grounded in real, verified knowledge.
It's like giving the LLM a reference library to check its facts against.
Exactly. It helps to prevent those hallucinations where the LLM just makes stuff up.
And in medicine, obviously, you can't have that. Accuracy is crucial.
Absolutely. And the last technique they mention is tool learning, which is giving the LLM access to external tools like medical calculators or specific databases.
So you're essentially expanding its capabilities by giving it access to these specialized tools.
Precisely. Okay, so we've covered prompt engineering, but what if that's not enough to get the performance you need? That's where fine-tuning comes in.
Right. Fine-tuning is like taking that general-purpose LLM and customizing it for a specific task.
It's like training an athlete for a particular sport. You can really improve performance with fine-tuning, but it's important to understand the different approaches and how they impact things like, your computational resources.
And the paper does a good job of breaking down those different approaches, right? Like full model fine-tuning versus these more lightweight methods like LoRa.
Yeah, choosing the right fine-tuning method is all about understanding your specific needs and constraints.
Okay, so we've picked our LLM, we've learned how to talk to it with prompt engineering, and we've even considered fine-tuning it. What's the last step in this whole process?
Deployment. And this is where we need to be extra careful, especially in healthcare, because we're dealing with sensitive patient data.
And the paper really stresses the importance of responsible deployment. They lay out all these key considerations.
Yeah, like data security and privacy are huge, right? You have to make sure you're complying with all the relevant regulations like IPay.
And of course, cost is always a factor. You have to balance the potential benefits of these LLMs with the practicalities of implementation.
Absolutely. And I think this is where the paper really shines. It gives you all the information you need to make informed decisions about these different LLMs, their strengths and weaknesses, their costs, and how to implement them responsibly.
It's been a really insightful overview so far. It's clear that LLMs have this incredible potential in healthcare, but there's also a lot to think about.
Yeah, we've got to approach this technology carefully and thoughtfully.
Well, there's definitely a lot more to unpack here, so let's dive into some specific examples and deeper insights in part 2. Stay tuned.
One of the things we talked about earlier, that prompt engineering technique, retrieval augmented generation, ARGI.
All right, that was a fascinating one.
It really gets to the heart of that whole hallucination problem.
Right, where the LLM could just make stuff up, which obviously in medicine is a huge concern.
Absolutely. And what I find so interesting about ROG is how it basically grounds the LLM's responses in, like, a solid foundation of actual medical knowledge.
It's like giving it a fact-checking team, right? Before it gives you an answer, it consults this curated database of research papers, clinical guidelines, maybe even real-world case studies.
Exactly. So you're not just relying on what the LLM has learned during its training, you're augmenting it with this external knowledge base.
And the paper really emphasizes how important it is to have a high-quality knowledge base.
Oh, absolutely. If you're feeding the LLM bad information, you're going to get bad results. It's all about making sure those sources are accurate and up to date.
So even with these techniques like RAG to improve accuracy, I still think it's crucial to emphasize that LLMs should be viewed as tools to support clinical decision-making, not replace it altogether.
Couldn't agree more. The human element, that doctor-patient relationship, that's still essential. The doctor brings their expertise, their understanding of the individual patient, and the LLM can provide insights and recommendations, but ultimately, the doctor is the one making the decisions.
That brings us to another really important point that the paper makes: the post-deployment phase. It's not enough to just implement these LLMs. We need to make sure they're being used effectively and responsibly.
Right, like training healthcare professionals is essential. They need to know how to interact with these LLMs, how to interpret their outputs, not just blindly trust whatever they say.
And I would argue that patient education is equally important. Patients need to understand how these LLMs work, what data they use, what the potential benefits and risks are.
Transparency is key, right? We need to move away from that black box perception of AI and have those open conversations with patients.
Speaking of transparency, the paper also delves into the issue of cost, which can be a major barrier for some healthcare organizations.
Right, they break down those different pricing models, proprietary versus open source.
And it seems like there's no easy answer. Choosing the right model from a cost perspective is this whole complicated calculation.
Exactly. The paper talks about those trade-offs between convenience and control. Proprietary models like GPT-4, they might be easier to get up and running, but you might have less flexibility and less control over your data.
Whereas open source models, you might have more control, but you need the technical expertise to manage them.
Right. It all comes down to each organization's specific needs and resources.
Now, shifting gears a bit, the paper also touches on this really crucial issue: bias. They cite some research about racial bias in LLM predictions, which could lead to some really serious problems in healthcare.
That's a huge concern, and it really highlights the need for careful evaluation and mitigation strategies. We need to be proactive in identifying and addressing these potential biases to make sure these LLMs are used fairly.
And this brings up the importance of diversity in AI development, right? Diverse teams, diverse data sets that can help challenge assumptions and reduce the risk of bias.
Absolutely. We need to make sure these technologies are benefiting all patients, regardless of their background.
So we've covered a lot of ground here. Those 5 core capabilities of LLMs: prompt engineering, fine-tuning, the complexities of deployment, and these ethical considerations around cost and bias. For you, what's the biggest takeaway from all of this?
For me, it's that realization that LLMs are powerful tools, but they are just that, tools.
Right. And like any powerful tool, they need to be used responsibly, ethically, and with a clear understanding of their limitations.
Exactly. We have a responsibility to make sure these technologies are used to improve healthcare for everyone, not to create more disparities.
I think that's a perfect transition to our final point for this deep dive. Beyond the technical aspects, let's talk about those bigger picture implications of LLMs in medicine, the impact on the human side of healthcare. It's interesting, right? We can talk about all the technical stuff, efficiency, accuracy, but at the end of the day, healthcare is about people.
Yeah, it's about that human connection. And that's what I'm really curious about. How will LLMs impact that doctor-patient relationship?
Right. Will patients be comfortable sharing their personal health information with an AI? Will they trust an AI's recommendations as much as they trust their doctor?
These are big questions, and I don't think there are any easy answers. But I think one key factor is going to be transparency. We need to be really clear with patients about how these LLMs are being used, what data are they looking at, how do they come up with their recommendations, and what role does the doctor play in all of this?
It's almost like we need a new kind of informed consent, specifically for AI. Patients need to understand what it means to have AI involved in their care before they can really agree to it.
That's a great point, and we need clear ethical guidelines too. It's not just about what we can do with these LLMs, it's about what we should do. We have to prioritize patient autonomy and make sure that AI is used to enhance the doctor-patient relationship, not replace it.
And the paper does touch on this a bit. They talk about the need for monitoring and making sure these LLMs are being used responsibly. But I think it needs even more emphasis. We need some real in-depth discussions about these ethical issues.
Absolutely, and it's a responsibility that falls on all of us, the people developing these models, the healthcare organizations using them, and of course, the doctors who are actually interacting with them.
It's a challenge, for sure. But I think the medical community is ready for it. We've seen this before with other new technologies, right? There's always an adjustment period, but ultimately it's about finding ways to use these tools to improve patient care.
Yeah, and I think there's a lot of excitement about the potential of LLMs in healthcare, but we have to be thoughtful about how we implement them.
So this deep dive has been a really fascinating look at LLMs in medicine, and I think it's just the beginning of a much larger conversation.
Oh, definitely. This field is moving so fast, and it's crucial that we stay informed and engaged.
And to our listeners, we encourage you to keep learning about this. We'll have links to the research paper and other resources in the show notes. And as always, we'd love to hear your thoughts.
How do you see LLMs shaping the future of healthcare? What are your hopes and concerns? Share your thoughts on our website or social media.
And until next time, stay curious and keep diving deep.